Welcome to this video on thermochemistry, heat and enthalpy. In this video, we will explore the fascinating world of thermochemistry, which is the study of the relationship between heat and chemical reactions. We will learn about the concepts of heat and enthalpy, and how they are used to understand chemical reactions. A graphic of a thermometer and a chemical reaction taking place. Thermochemistry is an important branch of chemistry that helps us understand the energy changes that occur during chemical reactions. The study of thermochemistry is crucial in many fields, including materials science, biochemistry, and environmental science. A graphic of different fields of science with thermochemistry highlighted. In this video, we will focus on two important concepts in thermochemistry, heat and enthalpy. Heat is a form of energy that is transferred from one object to another due to a temperature difference. Enthalpy is a measure of the heat content of a system at constant pressure. A graphic of a thermometer and a system with constant pressure. By understanding these concepts, we can gain insight into the energy changes that occur during chemical reactions. So, let's dive into the world of thermochemistry and explore the fascinating concepts of heat and enthalpy. In this segment, we will focus on the concept of heat and its units. Heat is a form of energy that is transferred from one object to another due to a temperature difference. The C unit of heat is the joule J. A graphic of a thermometer and the C unit of heat, the joule. However, in thermochemistry, we often use a different unit of heat called the calorie cal. 1 calorie is defined as the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. A graphic of a calorie and a thermometer. Another commonly used unit of heat is the kilocalorie kcal, which is equal to 1000 calories. This unit is often used in nutrition to measure the energy content of food. A graphic of a kilocalorie and a plate of food. It is important to note that heat is not the same as temperature. Temperature is a measure of the average kinetic energy of the particles in a substance, while heat is the transfer of energy from one object to another. A graphic of particles in a substance and a thermometer. In thermochemistry, we often use the concept of specific heat, which is the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. The specific heat of a substance depends on its chemical composition and physical state. A graphic of a substance and the concept of specific heat. By understanding the concept of heat and its units, we can better understand the energy changes that occur during chemical reactions. In the next segment, we will explore the concept of enthalpy and how it is used in thermochemistry. In this segment, we will focus on the concept of enthalpy and how it is used in thermochemistry. Enthalpy is a measure of the heat content of a system at constant pressure. The symbol for enthalpy is H, and it is measured in units of joules J or kilojoules kJ. The graphic of the symbol for enthalpy and the units of joules and kilojoules. Enthalpy is a state function, which means that it depends only on the initial and final states of a system, not on the path taken to get there. This makes it a useful tool for understanding the energy changes that occur during chemical reactions. A graphic of a system and the concept of a state function. The enthalpy change of a reaction, denoted as H, is the difference between the enthalpy of the products and the enthalpy of the reactants. If H is negative, the reaction is exothermic, meaning that heat is released. If H is positive, the reaction is endothermic, meaning that heat is absorbed. The graphic of a chemical reaction and the concept of enthalpy change. Enthalpy can be calculated using Hess's law, which states that the enthalpy change of a reaction is equal to the sum of the enthalpy changes of the individual steps of the reaction. A graphic of Hess's law and the steps of a reaction. Enthalpy can also be calculated using calorimetry, which is the measurement of heat changes during chemical reactions. Calorimetry involves measuring the temperature change of a substance when it is heated or cooled. A graphic of a calorimeter and the concept of calorimetry. By understanding the concept of enthalpy and its calculation, we can gain insight into the energy changes that occur during chemical reactions. In the next segment, we will explore the applications of thermochemistry in everyday life. In this segment, we will explore the applications of thermochemistry in everyday life. Thermochemistry has many practical applications, from cooking to energy production. A graphic of a stove and a power plant. One example of thermochemistry in everyday life is cooking. When we cook food, we are using heat to cause chemical reactions that change the flavor, texture, and nutritional content of the food. A graphic of a pan on a stove and a plate of food. Another example of thermochemistry in everyday life is energy production. Fossil fuels, such as coal and oil, are burned to produce heat, which is then used to generate electricity. A graphic of a power plant and a fossil fuel. Thermochemistry is also important in environmental science. The study of thermochemistry can help us understand the energy changes that occur during natural processes, such as photosynthesis and respiration. A graphic of a plant and a respiratory system. Thermochemistry is also used in materials science to understand the properties of materials, such as their melting and boiling points. A graphic of a material and its properties. By understanding the applications of thermochemistry in everyday life, we can appreciate the importance of this field of study. In the final segment, we will summarize the key concepts we have learned in this video. In this video, we have explored the fascinating world of thermochemistry, heat, and enthalpy. We have learned that thermochemistry is the study of the relationship between heat and chemical reactions, and that it is an important branch of chemistry with many practical applications. A graphic of a thermometer and a chemical reaction taking place. We have learned that heat is a form of energy that is transferred from one object to another due to a temperature difference, and that enthalpy is a measure of the heat content of a system at constant pressure. A graphic of a thermometer in a system with constant pressure. We have learned that enthalpy is a state function, and that it can be calculated using Hess's law or calorimetry. We have also explored the applications of thermochemistry in everyday life, from cooking to energy production. A graphic of a stove and a power plant. By understanding the concepts of heat and enthalpy, we can gain insight into the energy changes that occur during chemical reactions. Thermochemistry is a crucial field of study that helps us understand the world around us. A graphic of different fields of science with thermochemistry highlighted. Thank you for watching this video on thermochemistry, heat, and enthalpy. We hope you have gained a better understanding of this fascinating field of study.